A new discovery from NASA shows a previously unseen structure centered in the Milky Way. The images taken from the Fermi Gamma Ray Telescope show a structure so massive it spans some 50,000 light years. So what exactly is it? Joining me on the phone is Dr. Paul LaViolette. He is the president of the Starburst Foundation and the author of Earth Under Fire. Dr. Violette, thank you for joining me. If you could you tell us what we're looking at?
These are gamma ray emission from cosmic ray electrons. They're very high energy, which I believe is an emission from the galactic core, and basically forming what I call a superwave. It's a wave of cosmic rays that moves out from the core in all directions. It's sort of symmetrical, and it produces what's called a diffuse gamma ray emission around our galaxy that you see in all directions. So sort of like we're inside this sphere of cosmic ray electrons that are moving outward. But the reason we see these bubbles in this particular direction, where it's more intense than the other gamma ray emission, is because the cosmic ray electrons escape more easily along the polar directions. Because there's less impediment from the magnetic fields in the core in that direction.
Have any of these bubbles been detected before, or is this really a first for NASA to see them?
Well, we see a similar thing in other galaxies that have active cores, like, for example, Centaurus A. There's similar bubbles around it, and we're viewing Centaurus A edge on. It's the closest galaxy that indicates explosive activity in its core, closest to us.
Oh, how does this affect our solar system?
This is a recurrent phenomenon, and the most recent large superwave impacted us at the end of the Ice Age, which was a time when we had a large die-off of the large megafauna, which I don't believe that was directly caused by the superwave, was an indirect effect. It involved also the sun. This is something that activates the sun, brings cosmic dust into the solar system, causes climatic change, a whole host of things. And it's something we should be concerned about for the future because this is a recurrent event. It makes the scientific community more aware that core explosions from our own galactic core take place much more frequently than they had thought on a shorter time scale. Whereas before they were thinking time scales of 100 million years between explosions, now they're realizing they can be less than 100,000 years. And in the case of this, you can show that this particular one occurred 40,000 years ago. So it brings it closer to home, and realizing that since it's periodic, we're due for another event in the near future.
Well, Dr. LaViolette, thank you so much for your time, and thank you for your insight.